Simon Ohm, he has told that there is a relationship between the potential difference and the current. What is that potential difference? So that potential difference is nothing but the voltage when it is being offered to the resistance, the drop takes place regarding the voltage. And when we say that the voltage drop is taking place, that means potential difference occurs. Now, this potential difference and this current flowing through the conductor, he has given the relation that potential difference is directly proportional to the current flowing through the conductor. He then explained that what is the definition for the Ohm's law. So according to this equation, he has very much clearly mentioned that the physical quantity of a material, as long as it remains constant, the potential difference across the conductor is directly proportional to the current flowing through the conductor. So this is called as the Ohm's law. Now, when I am saying about the Ohm's law, he said that V is directly proportional to I. Now, we are going to see it through the equation form. So now here in the figure we have seen that, or here in the screen we are finding that V is equal to IR, because we have taken the proportional sign V is proportional to R. When we replace the proportional symbol, that time it is replaced by equal constant. That constant is termed as R, and this R is nothing but the resistance of that material. So this resistance of the material is very much clear that we are having unit for that resistance, that is called as the ohm. Now here it is given in the figure. If you look to it, you will find that R is equal to V up, because we have got V is equal to IR, because equal and R term has appeared in the expression. Now I want to find out the equation for R. So when I change this format, I find that R is equal to VI. Now R is equal to VI. Then we come to the conclusion that what is the unit for R? So first of all, we say that V is nothing but voltage, and voltage is the term which we have taken in the form of potential difference. So V is the voltage. Current is taken in terms of ampere. So if you take the ratio of 1 volt to the 1 ampere, we get an equivalent of this ratio that is named as ohm. So 1 ohm is equal to 1 volt per 1 ampere. Now, if I will take the reciprocal of the resistance, I find that 1 upon R is termed as conductance, and this conductance is represented by C, and therefore this C, that is known as the conductance of material, it is represented by reciprocal of resistance. So you will find that this is C is equal to 1 upon R, which is having the unit Siemens, or Ohm inverse. So hence we have found out by Ohm that there is a resistance for the material through which the current is going to flow when we apply the potential difference across that material. Now next is that when we want in terms of conductance only, we have to take the reciprocal. So hence we have got it, and we have mentioned the unit also, that is called as the Siemens. Now if you look into the figure, you will find that the dark line, if you take the graph, that is V versus I, you find that good conductor is very much linear. Means linearity is shown by the Ohm's law for the good conductor because it is coming in the straight line. Now next is that he has given the physical origin of the Ohm's law. Now when he has said that what is the physical origin, so here it is very much said that we are going to take any material, suppose we are going to take a good conductor, and with the help of the good conductor we come to the point that copper material is made up of number of atoms. Now you know that atoms is having nucleus in which protons and neutrons are present. Protons and neutrons, due to this, the nucleus is positively charged. Around the nucleus, electrons are bounded. They are following the principle of chemistry, that is sp configuration. And if you notice it, you will find that in the last octet or in the last orbit, there are few electrons which are loosely bound to the nucleus. Now when we say that it is loosely bound to the nucleus, means what is going to happen? These loosely bound electrons, due to the thermal energy, they get detached from the atom. When they get detached from the atom, these electrons are said to be free electrons. When these free electrons are detached, they are free to move anywhere. Now you know that for a copper material there are crores of atoms, and therefore free electrons are large in numbers, and these free electrons are responsible for the flow of the current. But when we come to the conclusion that we have earlier we have stated that the net current due to the electrons is zero when there is no application of external electric field. So hence, as long as we are not going to give the supply externally, that time we find that we have to do something. We have to prepare a circuit. And when we prepare a circuit, that time we are considering that we are applying a battery voltage having V to that resistance of the copper. Now copper resistance, when we say that, because these electrons definitely is going to oppose the flow of electron due to the electrons coming from the batteries. Now this battery electrons, they are having high velocity, but when we consider that velocity of the electron, now you know that as compared to the battery voltage, the number of electrons coming from the battery is very much large as compared to the voltage, electrons that are traveling in the opposite direction of the flow of the battery. Now flow of the battery, we know that the current is due to the two reasons. One is due to the holes, that is called as the positive charges, and other is the current due to the negative charges, that is called as the electrons. When we say that there is an electron, this means that electron is reasonable, or if we say that it is responsible for the flow of current. When we say that the current is due to the electron, then we say that electric current due to electron. But when we say that it is due to the holes, then we say that it is positive. Therefore, we have distinguished according to this holes and negative means electrons, the current, distinguishing factor it is. So, depending upon that, we say that there are two types of current. One is called as the conventional current. That conventional current is due to the positive charge, and other current is due to the negative charge, that is called as the electrons. Now, these electrons have some mass, and this mass of electron, when it is subjected to the external electric field, we say that there is an intensity. When we say that there is an intensity, this means that the force is going to act on the charge, that is electron from the copper or material, due to the external electric field that is given by the battery. So hence the intensity, when these two charges come across each other, we find that according to that Coulomb's law also, there is a force. Force may be attractive, may be repulsive. So the force which is experienced by the test charge, we call it, which is minority in comparison to the flow of charges, which is majority, that gives rise to force, and that force equation is given here. If you look to this, F is equal to E into E. Now you will aware about what is meant by force. Force is nothing but basic formula, that is mass into acceleration. So I want to substitute it. So I get A is equal to E upon M. Now here, when we say that, we have got a new equation, AE upon M. Now this charge or electron, which when comes across the majority carriers, there is a collision between these two electrons, and this gives rise to drift velocity. But when there is a collision, we say that there is a time between the two collisions, and it is represented by tau. So we call this tau as the average time between the two successive collisions. Now, this average electrons will acquire a drift speed, means minority carriers, that is electrons from the copper material or the material, they will result into what? They will result into a drift velocity. And this drift velocity is nothing but, what is the drift velocity we call it? This drift velocity is termed as velocity due to the electrons which are making collision of the material, and that's why we say that there is a velocity, there is a time interval between the two collisions, and this collision says that which is defined by tau. Now here tau is the average time between the two collisions we have said. So therefore, these electrons are going to have some velocity, and that velocity is termed as drift velocity. Now what is drift velocity? We know that basic formula of velocity is nothing but what? Distance upon time. We also know that acceleration is what? It is nothing but velocity upon time. So here I am using the equation for Vd, that is acceleration into time between the two collisions, and that time is taken as tau. So this tau Vd is equal to a tau, and now I am substituting the value. What is that value? So here we have seen that earlier. Here it is a value. We are substituting into Vd. Vd is equal to a tau. So substituting a value, we get a new equation, and that equation is called as the Vd is equal to small e into capital E tau upon n. Now, if I want to write this equation in terms of current density, so what I will get? Vd is equal to J upon Ne. Last time we have seen the current density formula. So directly we substitute it and we get a new equation, that is Vd is equal to J upon Ne. Now this J upon Ne is nothing but this E tau upon m. We have equated it. And finally, if I write in the form of intensity, just I will change the position of this equation or the terms in that equation. I get E is equal to m upon E square n tau bracket multiplied by J. Looking to this bracket, you will find that this bracket has a constant terms. So that constant is replaced by a new term rho. It is replaced by a new term rho, and that rho is called as the resistivity of that material. When I say that it is the resistivity of the material, that rho I am substituting in this equation, and I find